Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So my dear students, quickly let me know in the chats if all of you can hear me. If I'm perfectly audible, visible to every one of you. Let me know quickly in the chats, my dear students, if all of you can hear me. If I'm perfectly audible, visible to everyone. Everyone. Quickly let me know in the chats. Good evening, my dear students. Good evening and welcome back. Good evening and welcome back. So, am I perfectly audible, visible? Yeah? Am I perfectly audible, visible, people? All right. Perfect. So, my dear students, as you all must be knowing, today's session is going to be a very short and precise session. I'll not take more than one and a half hour. And in this particular session, I'll be giving you the most expected questions which are to be asked in the NEET 2025 examination, as per my experience. Okay? Perfect. So, is everyone ready for the session? I would want to know in the chats. I would want to know in the chats, people. Everyone. Well, this is not going to be a long marathon. The session duration is going to be one and a half hours only, because I've come up with almost like 45 to 50 questions, which I feel are super important to be solved with all of you, because you can expect the questions directly, indirectly from the today's session for sure. So let me know quickly in the chats if all of you are ready. I want the chats to move fast. Yeah? Let me know quickly in the chats, people, with some fire emojis. Everyone, people. Amazing. Someone is saying, sir, I'm very scared of at this particular point of time. There is no need to be scared. It's okay. You're not the only one who's going to write this examination. There are 23 lakh students who are going to write. Yeah? Don't worry. Everything will be fine. Don't think about the consequences right now. Don't think about the results right now. Just focus on the process, right? Make sure these 10, 12 days are to be utilized in a proper direction. That should be the only thing in your mind at this particular point of time. All right? Perfect. Perfect, guys. All right. So one thing, guys, the sessions which I have been posting from past few days, like those 20 marks in 8 minutes, 30 marks in 15 minutes, like that. Are you all following those sessions? I want to know in the chats first. Are you all following those sessions? Just tell me that first of all, with a yes or no. Are you all following those sessions? Please and please do follow those sessions, okay? They are very important. Those sessions are going to save a lot of time of yours. Those sessions are going to save a lot of time of yours, people. Okay? So please try to follow those sessions with sincerity. Perfect. All right. So let's get going then. Let's get started with the today's session. Okay, let's get started with the today's session. And my dear students, first of all, I will be starting with your inorganic chemistry. So basically, in the today's session, I shall be discussing inorganic and physical chemistry with you. Organic chemistry questions will be done by HSP sir, right? Not in this session. He'll be taking it tomorrow or day after tomorrow. Okay, so today it's going to be your most predicted questions of your physical chemistry and inorganic chemistry, right? So try to have the proper eye on the questions which I'll be showing you over here. All right. Well, the first question with which I'm starting the session, let's have a look on the question, my dear students. And I believe this is the question which every one of you can easily solve. Have a look on the question. The number of anti-bonding electrons present in O2 molecule will be. What do you think? How many anti-bonding electrons are present in O2 molecule? Well, my dear students, you must be knowing, in order to know the number of bonding, the number of anti-bonding electrons in a molecule, you have to write the molecular orbital configuration first, right? You have to write the molecular orbital configuration first. After writing the molecular orbital configuration, then only you can decide how many bonding electrons, how many anti-bonding electrons are present in a molecule. Perfect. Since you know, in case of O2, O2 is a 16 electron species. O2 is a 16 electron species. First of all, let me tell you, there are some 6 anti-bonding electrons. And how there will be some 6 anti-bonding electrons? My dear students, as I told you, for that, you have to write the molecular orbital configuration for this O2 molecule. If you have a look properly, in case of O2, there are in total 16 electrons. Now you have to fill these 16 electrons in these molecular orbitals. And every molecular orbital can accommodate maximum of 2 electrons. Have a look. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, sigma pi 2px2, pi 2py2, pi star 2px1, pi star 2py1. This is your molecular orbital configuration for your O2 molecule. And you have accommodated all these 16 electrons in these molecular orbitals. Now, after accommodating all these 16 electrons in these molecular orbitals, you can just count the number of anti-bonding electrons. So, these two are anti-bonding. These two are also anti-bonding. This one is anti-bonding and this one is anti-bonding. So, 2 plus 2, 4, 4 plus 1 plus 1 comes out to be 6. So, there are in total 6 anti-bonding electrons present in O2 molecule. My dear students, one more thing can be asked here. That is the bond order. You know, bond order is nothing, that is half of number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital. Right? Perfect. It's a very simple and basic question, and I believe every one of you would have solved it properly. Tell me the answer of this particular question quickly. Tell me the answer of this particular question, guys. What is the correct thermal stability order for the hydrides of group 16? I'm given with the hydrides of group 16. You have to tell me the thermal stability order. You have to tell me the thermal stability order of the hydrides of group 16. My dear students, the question is pretty much simple, right? Hydrides of group 16, that is H2O, H2S, H2SE, right? H2TE, H2PO. These are the hydrides of group 16. And you know, when you move from top to the bottom, what happens to thermal stability? Does it increase or decrease? Quickly. When you move from top to the bottom, what happens to thermal stability? Quickly, my dear students. Thermal stability decreases. Thermal stability decreases. Why? Because the bond dissociation energy decreases. On moving from top to the bottom, thermal stability decreases because the bond dissociation energy on moving from top to the bottom, that decreases. So the correct answer of this particular question has to be option C for sure. Water is going to be maximum thermal stable, followed by your H2S, followed by your H2SE, H2TE, and H2PO. Perfect. So this is one question, right, which you have to remember. Looking at the next question, my dear students. The number of species from the following which have square pyramidal geometry, which have square pyramidal structure. So first of all, square pyramidal, right? Square pyramidal. The molecules of the type AB5L1. The molecules of the type AB5L1. Their structure is square pyramidal. Their structure is square pyramidal. Now you have to check what is the type of these molecules, and accordingly you can check how many molecules are there which have got square pyramidal geometry. Have a look exactly. If you talk about PCl5, phosphorus is a central atom. It has got some 5 valence electrons. It has got some 5 sigma bonds, right? So all the 5 valence electrons are utilized to form 5 sigma bonds. So there is no lone pair on phosphorus. The type of the molecule is simply going to be AB5L0. And if it is AB5L0, it is not going to be square pyramidal. Number one. Talk about BrF4 negative, right? If you talk about your bromine, my dear students, how many valence electrons it has? 7. Since there is a negative charge, so 7 plus 1 makes it 8. So how many surrounding atoms are there? 4 surrounding atoms means 4 sigma bonds. So out of 8 valence electrons, 4 valence electrons have been utilized to form 4 sigma bonds. So 4 will be left as such in the form of 2 lone pairs, right? So the type of the molecule is nothing. It is AB4L2. If it is AB4L2, it is again not going to be the square pyramidal. It's again not going to be square pyramidal. If you talk about your IF5, in case of IF5, the type of the molecule directly is going to be AB5L1. PRF5, the type of the molecule again is going to be AB5L1. XeOF4, the type of the molecule is going to be AB5L1. So how many species are there which have got the type AB5L1? I would say there are 3 species, right? So the correct answer has to be option 2. I hope I'm clear with this. And please have an eye on this sort of a question, people. This can be asked in your upcoming NEET examination. All right. What about this particular question? I'm given with certain elements: boron, carbon, nitrogen, lithium, beryllium, oxygen, fluorine. The correct order of their first ionization energy. The correct order of their first ionization energy is, what do you think? My dear students, if I talk about lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, all these elements, they belong to same period. They belong to same period. Now, you know, along the period, on moving from left to right, generally ionization energy increases. Ionization energy increases. So what is the expected order? This is the expected order of the first ionization energies. This is the expected order. But is it going to be the actual order? This is not going to be the actual order. Actual order is going to be something like this. First of all, lithium, then comes boron, then comes beryllium, then comes carbon, then comes oxygen, then comes nitrogen, and then comes fluorine. Why is that? Why is that? What is the logic behind that? Because if you talk about beryllium, its outermost configuration is 2s2. If you talk about boron, its outermost configuration is 2p1, right? 2p1. So my dear students, 2s2 means something like this. 2p1 means something like this. So among these two configurations, which one is more stable configuration? I would say this is more stable configuration. So to take electron out from this configuration, more energy is required. That's why beryllium has got more ionization energy than that of boron. Similarly, in case of nitrogen, it has got half-filled configuration. And to take electron out from half-filled configuration, more energy is required. That is the reason why nitrogen has got more ionization energy than that of what? Than that of your oxygen. So the correct answer of this particular equation, as I can see the options, is option number 4. Okay? I hope this is clear to everyone. I hope this is clear to everyone, people. I'm moving on to the next question. I am moving on to the next question. What do you think about this particular question? The question which all of you can easily solve, I believe, right? That's why your inorganic chemistry is considered to be the scoring subject, because it does not require a lot of time to solve. You are given with a metal ion whose calculated magnetic moment is 4.9 Bohr magnetron. How do you calculate magnetic moment? Under root of n into n plus 2, right? This is how you calculate the magnetic moment. And as per the question, the magnetic moment is 4.9 Bohr magnetrons. Perfect. This n represents the number of unpaired electrons. Now tell me, what should be the value of n such that this whole term becomes 4.9? My dear students, it's pretty much simple. If you take the value of n as 5, if the value of n is taken as 5, how much it comes? Sorry. If you take the value of n as 4, if you take the value of n as 4, it becomes under root of 4 into 4 plus 2. 4 plus 2 is 6, 6 4s are 24. So it is root of 24. Root of 24 will be 4.9. So there must be some 4 unpaired electrons in the metal ion. There must be some 4 unpaired electrons in the metal ion. If I'm clear, let me know once in the chats. Yeah? All clear, people? I'm moving on to the next question. Let's have a look on the question. What is the correct electronic configuration of the central atom in case of K4FeCN6? K4FeCN6 based on crystal field theory. My dear students, when you calculate the oxidation state of iron here is in di-positive state. Iron in di-positive state, what will be its outermost electronic configuration? It will be 3d6, 4 is 0. It will be 3d6, 4 is 0, 4p0, 4d0. Right? This is the outermost configuration of your iron di-positive. This is the outermost configuration of your iron di-positive. Now, my dear students, here you have got d6 configuration. 1, 2, 3, 4, 5, and 6. This is your d6 configuration here. Right? D6 configuration. Now, due to the crystal field splitting, what is going to happen? What is going to happen, my dear students? This is your T2G set, this is your EG set. This is your T2G, this is your EG. Now, if you look carefully, is it a strong field ligand or weak field ligand? It's a strong field ligand. If it is a strong field ligand, pairing will happen. If it's a strong field ligand, pairing will happen. So all these 6 electrons, 1, 2, 3. Now, fourth one was supposed to go here, but it will go here only, right? So the configuration becomes T2G6 and EG0. Perfect. Because the ligand here is strong, it is going to cause the pairing of electrons. It is going to cause the pairing of electrons. I believe this is clear to everyone. So the correct answer of this particular question will be T2G6 EG0 configuration. Okay. I'm moving on to the next question, people. I'm moving on to the next question, people. Tell me the answer of this. It is a memory-based question. Quickly. The set which does not have ambidentate ligands. So where do you not see ambidentate ligands? Which set does not represent your ambidentate ligands? It is a simple basic question which I believe every one of you can easily solve. Tell me the answer of this. Tell me the answer of this quickly. Majority is coming up with the correct answer. So the correct answer is option A, your C2O4 dinegative ethylene diamine and your aqua, water, right? They are not your ambidentate ligands. Look at the next question, guys. The magnetic moment is measured in Bohr magnetron. Spin magnetic moment of iron in FeH2O6 tripositive, FeCN6 trinegative complexes. We have to calculate the spin magnetic moment. So first of all, iron here is in tripositive oxidation state. Here also iron is in tripositive oxidation state. And when iron is in tripositive state, its configuration will be 3d5, 4s0, 4p0, 4d0. Right? This is the outermost configuration of Fe tripositive. Iron is basically 3d6, 4s2. So take 3 electrons out, it becomes 3d5 configuration. Now, my dear students, this is your 3d5 configuration which I'm mentioning over here. 1, 2, 3, 4, 5. Perfect. Now, 2 possibilities are going to arise here. This aqua water here, it's a weak field ligand. And this cyanide here, it's a strong field ligand. Weak field ligand is not going to cause any sort of pairing. Weak field ligand is not going to cause any sort of pairing. Right? Weak field ligand is not going to cause any sort of pairing. But strong field ligand is going to cause the pairing. Strong field ligand is going to cause the pairing. And my dear students, how do we exactly solve this? Have a look. This is your D5 configuration. This is your D5 configuration, right? This is your 3D5. This is 4S0. This is your 4P0. And this is your 4D0 as well. This is your 4D0 as well. Now, over here, water is a weak field ligand. It's not going to cause pairing. So the hybridization involved is going to be sp3d2. So in the first case, the hybridization is sp3d2. And my dear students, how many unpaired electrons are here? You have got some 5 unpaired electrons. So n value is 5 in the first case. N value is 5 in the first case, right? If n is equal to 5, what will be the spin magnetic moment? Root of 5 into 5 plus 2. That comes out to be 5 point. Root of 5 into 5 plus 2. That comes out to be 5.92 Bohr magnetrons. Okay. Here you have got a strong ligand. So pairing will happen. So one of the electron will go here. One electron will go here. Hybridization involved is going to be D2sp3. D2sp3, right? So there will be only one unpaired electron. And if there is only one unpaired electron, spin magnetic moment will be under root of 1 into 1 plus 2, which comes out to be 1.732. So option 4 is the one that is going to be the correct answer of this particular question as well. I believe this is super clear to everyone. Right? Even without doing all this stuff, you could have solved the question. See, weak field ligand does not cause pairing. So there will be unpaired electrons. Here there will be less unpaired electrons. More unpaired electrons means more spin magnetic moment. Less unpaired electrons means less magnetic moment. So first one should be more. Second value has to be less for sure. Right? I believe this particular question is clear to everyone. Now, my dear students, again, a simple and basic question, but you can expect this sort of a question in your examination as well. So what do you think about this one? Quickly have a look. The difference between electron gain enthalpies. The difference between electron gain enthalpies will be maximum between. What do you think? My dear students, if I look at all the options, chlorine and neon, and here chlorine and neon, the electron gain enthalpy of neon is least, right? Because it already has got the noble gas configuration. It won't I mean, it won't be willing to accept the incoming electron. But in case of chlorine, electron gain enthalpy is more. That too more than that of fluorine. Electron gain enthalpy of chlorine is more than that of fluorine. So where is the difference maximum? In the first case or in the third case? In the first case or in the third case? Guys, be careful with this question. I know a lot of students will mark it wrong. A lot of students will mark this as the answer. But this won't be the answer. Answer is going to be this one. Answer will be this one. Because electron gain enthalpy of chlorine will be more than that of fluorine, right? So the difference here comes out to be more. Difference here comes out to be more. So it is actually the third option that is going to be the correct answer of this particular question. All right. Now, my dear students, tell me the answer of this one. Number of ambidentate ligands in the representative metal complex. So how many ambidentate ligands do you see here? Ethylene diamine. Is it the ambidentate? No. This one is the ambidentate. And how many these are? These are 4. So there are 4 ambidentate ligands in this particular complex over here. Right? As simple as that. Perfect. Tell me the answer of this one. Which of the following is correct regarding the thermal stability of hydrides of group 15? So you are given with the hydrides of group 15. What happens to their thermal stability down the group? What happens to the thermal stability of hydrides down the group? Quickly in the chats. As I told you, like in case of your group 16, down the group, thermal stability decreases. Similarly, in case of group 15 hydrides, down the group, thermal stability decreases. So NH3 is going to be maximum thermally stable, followed by PH3, followed by ASH3. Okay. Again, a simple basic question only. No need to think a lot. This sort of a question is the most repeated question from your inorganic, my dear students. So have an eye on this and tell me its answer. Bond dissociation energy of the halogen molecules. Bond dissociation energy of the halogen molecules. So you have got F2 molecule, you have got Cl2, you have got Br2, you have got I2, right? What is going to be their order? First of all, expected order. What is the expected order? What is the expected order? Expected order is F2 should have more bond dissociation energy than that of Cl2, then that of your Br2, then that of your I2. This is the expected order. This is the expected order, right? But in reality, Br2 has got maximum, right? Br2 has got maximum. Sorry. In reality, Cl2 has got maximum, followed by Br2, and then comes your F2, and then comes your I2. This is the actual order. Because of the small size of fluorine, right? The electron density on fluorine atoms is more, due to which repulsions will be more, bond dissociation energy will be less. So have an eye on this particular question as well. This is the expected order, but in reality, this is the actual order. Okay, because of the smaller size of fluorine, right? Electron density on fluorine atoms is more, due to which repulsions will be more and bond dissociation energy will be definitely less. I'm moving on to one more. The number of Cl double bond O bonds. The number of Cl double bond O bonds in hypochlorous acid, chlorous acid, and chloric acid, and perchloric acid. The number of Cl double bond O. Well, in order to solve this question, you should know definitely the structures of these compounds. And these structures I've discussed in your redox reaction chapter as well. Okay. And when you look at their structures, this is your HOCl, hypochlorous. This is your HClO2, that is chlorous acid. This is your HClO3, that's chloric acid. This is your HClO4, that is perchloric acid. So how many Cl double bond O's are there? In this one, there is no Cl double bond O. Here you have got 1, here you have got 2, here you have got 3. So 3 plus 2 plus 1, that comes out to be 6. So there are 6 double bonds between chlorine and oxygen in case of all of these. Okay, in case of all of these. So have an eye on these structures as well. Okay, what do you think is the answer of this one? The spin-only magnetic moment value of FeCN6 tri-negative is 1.74, whereas FeH2O6 tri-positive is 5.92. In both the complexes, iron is present in tri-positive state. So first statement is correct, as well as second statement is correct. But second statement, that has got nothing to do with the explanation of the first statement. Okay, that has got nothing to do with the explanation of the first statement. So both A and R are true, but R is not the correct explanation of the first statement. Right, people? Perfect. Look at this particular question. In which of the following octahedral complexes the magnitude of delta naught will be maximum? Crystal field splitting. Where is the crystal field splitting maximum? Strong field ligands, they are going to cause more splitting. Strong field ligands are going to cause more splitting, right? And if strong field ligands are going to cause more splitting, that means there only delta naught value will be maximum. So where do you see which of the following is the maximum strong field ligand? It is going to be Cn negative, right? So over here in this particular complex, delta naught value will be the maximum. I hope this one is clear. My dear students, look at this particular question. Look at this particular question. An aqueous solution freezes at minus 0.186 degrees centigrade. Kf value is given, Kb is given. What is the elevation and boiling point? What is the elevation and boiling point? Have a look on this particular question as well. So first of all, if I talk about delta Tf, depression in freezing point, which is basically freezing point of solvent minus freezing point of solution. As per the formula, it's nothing but Kf multiplied by molality. Now, since we are talking about the aqueous solution, so the solvent used is water, whose freezing point is 0. So what do we get? We get minus Tf solution. Minus Tf solution is equal to Kf. Kf is 1.86 multiplied by molality of the solution. Freezing point of the solution is minus 0.1. So minus minus becomes plus. So it is 0.186 is equal to 1.86 multiplied by m. So molality of the solution is 0.186 divided by 1.86. The value comes out to be 0.1. This is the molality of the solution. Since you got the molality of the solution, what am I supposed to calculate? I want to calculate delta Tb, and elevation in boiling point delta Tb is nothing but Kb multiplied by m. What is the value of Kb? Kb is, this is plus 0.512. 0.512. Molality of the solution is how much? That is 0.1. The overall value comes out to be 0.0512, right? So do you see any option like this? 0.0512 degrees centigrade. This is the elevation in the boiling point, which I was supposed to calculate. A very simple basic question from the chapter solution. Expect this sort as well. Expect this sort as well. My dear students, look at this particular question. 4.5 moles each of hydrogen and iodine is heated in a sealed 10-liter vessel. At equilibrium, 3 moles of HI were found. At equilibrium, 3 moles of HI were found. The equilibrium constant for the reaction you have to calculate. So how exactly you are going to solve this? If you look at the reaction is H2 gas plus I2 gas is in equilibrium with 2 times HI gas. This is the reaction. Now, my dear students, at time t is equal to 0, I'm starting with 4.5 moles each of reactants. I'm starting with 4.5 moles each of reactants. Now, at equilibrium, let's assume that out of 4.5 moles of H2, X moles have reacted. So at equilibrium, I'm left with 4.5 minus X moles of this. Similarly, 4.5 minus X moles of this. Since 1 mole gives 2 moles, so X moles are going to give us 2X moles. So these are the moles of reactants products present in the container at equilibrium. Okay. Now, as per the question, they have mentioned that 3 moles of HI were found at equilibrium. So number of moles of HI at equilibrium, as per the question, is 3. And we know number of moles of HI at equilibrium is basically 2x. So 2x is equal to 3. X is equal to how much? 1.5. 3 by 2, that's 1.5. So put the value of x here. 4.5 minus 1.5 comes out to be 3. This will be also 3. This will be also 3. So these are the moles of reactants products present in the container at equilibrium, right? My dear students, if I divide these moles with the total volume of the reaction vessel, that is 10 liters, what do I call them as? These are what I call as the concentrations. Now, these are the concentrations of reactants products in the container at equilibrium. Since you got the concentrations of reactants products at equilibrium, so if I write the Kc expression, Kc is concentration of HI at equilibrium, that's 3 divided by 10, whole raised power, its stoichiometric coefficient, that's 2, divided by concentration of H2 at equilibrium, which is again 3 divided by 10, raised power stoichiometric coefficient, that's 1. Similarly, it is 3 by 10, That is the concentration of H2 at equilibrium raised by stoichiometric coefficient 1. So all this and all this gets cancelled out. Kc value is coming out to be 1. So this sort of equation, I believe, this similar sort of question can be asked in your upcoming NEET examination. So have an eye on Kp Kc calculation as well. Have an eye on Kp Kc calculation as well. Okay. My dear students, look at this one. Look at this particular question. What do you think? I'm looking at your chats. I am looking at your chats. What do you think about this one? The volume of hydrogen liberated at STP by treating 2.4 grams of magnesium, with HCl. And we know when magnesium reacts with HCl, it leads to the formation of MgCl2, and with this you get H2 gas. With this you get H2 gas. Okay. Now as per the question, we had 2.4 grams of magnesium. So how many moles of magnesium we have? Mass of magnesium divided by molar mass of magnesium. So basically we are starting with 0.1 moles of magnesium. We are starting with 0.1 moles of magnesium. Now as per the reaction stoichiometry, 1 mole of magnesium gives 1 mole of H2. Therefore 0.1 mole magnesium is going to give us 0.1 mole H2. As per the question, was I supposed to calculate moles of H2? No. I'm supposed to calculate volume of H2, right? I'm supposed to calculate volume of H2. How do I convert moles into volume? I'll say volume of H2 would be moles of H2 multiplied by 22.4. The value comes out to be 2.24 liters. So this is the volume of H2 which will be produced during this particular reaction, which again I was supposed to calculate. I hope this sort of equation also can be done by you. Okay, one special compound, chromyl chloride, CrO2Cl2. CrO2Cl2. What is the oxidation state of chromium here? CrO2Cl2. In case of your chromyl chloride, what is the oxidation state of chromium? Tell me in the chats, quick. Quickly, my dear students, everyone. Everyone. It's absolutely option A. It's absolutely option A. This is your CrO2Cl2, right? Look at this double bond. Due to this double bond, chromium gets +2. Due to this double bond, chromium gets +2. Due to this single bond, chromium +1. Due to this single bond, chromium +1. So in total, the total charge on chromium here is +6. So +6 is the oxidation state of chromium in case of your CrO2Cl2. Have an eye on this sort of equation from the chapter kinetics. You have got a first order reaction, A gives B. This is your first order reaction, whose rate constant K is also given to me, 10 raised power -2 second inverse. Initially at time t is equal to 0, what is the amount of reactant given? Amount of reactant is 20 grams. Okay. At what time the amount of reactant left will be? At what time the amount of reactant left will be 5 grams? This is the question. At what time the amount of reactant left will be 5 grams? So simple, you are going to use the integrated rate equation, my dear students. And in case of the first order kinetics, T is equal to 2.303 divided by K. It is a log of A0 divided by 80. So I would say T is equal to 2.303 divided by K. K is 10 raised power -2. Log of, what is A0? A0 value is 20, 80 value is 5. So 5154. So this comes out to be 2.303 multiplied by 10 raised power 2. Log of 4 is how much? 0.6. Log of 4 is 0.6. So this will be 230.3 multiplied by 0.6. Now solve this, get the answer in seconds exactly. So this is the time required for the amount of reactant to reduce from 20 grams to 5 grams. Am I clear with this? Am I clear with this? The answer of this particular question after solving comes out to be 138 seconds, my dear students. Right? I'm moving on to one more question. Have an eye on this as well, this sort of a question. The volume of 0.02 molar aqueous HBr required to neutralize 10 ml of 0.01 aqueous barium hydroxide. So this is the case of neutralization. This is the case of neutralization. So first of all, tell me, what is the N factor of HBr here? It's 1. What is the N factor of barium hydroxide? It's 2. Volume of HBr needs to be calculated. Molarity of HBr is equal to 0.02. Volume of this barium hydroxide is given to me as 10 ml, right? And molarity of this barium hydroxide is equal to 0.01. Perfect. Now, molarity multiplied by n factor gives me normality. So normality here is 0.02 and normality here will be molarity multiplied by n factor. That comes out to be 0.02. Perfect. Now, if I use the equivalent concept simply says that N1V1 has to be equal to N2V2. If N1V1 has to be equal to N2V2, so I would say 0.02V1 has to be equal to 0.02 multiplied by V2. V2 is 10. So this term gets cancelled out. V1 value directly comes out to be 10 ml. V1 value directly comes out to be 10 ml. So this is how you are going to solve this sort of equation over here. Perfect. I hope it's also clear to everyone. And if it is clear, tell me the answer of this particular question. Tell me the answer of this particular question. The reduction potentials of the half cells are given. The number of metals which will be oxidized by NO3 negative. NO3 negative. These are the reduction potentials of the ions which are given to me. These are the reduction potentials. These are the reduction potentials of the ions which are given to me. Now you have to tell me which all ions will be oxidized by NO3 negative. The reduction potential of NO3 negative is 0.97, right? This particular ion, which is your V di positive, its reduction potential is less than this. Fe tri positive, its reduction potential is also less than this. 0.80, which is the reduction potential of Ag positive, which is also less than this particular value. So those particular ions whose reduction potential will be less than 0.97, they'll be getting oxidized. So in total, there'll be 3 ions which will be oxidized by NO3 negative, right? There'll be in total 3 ions which will be oxidized by NO3 negative. I just compared the values and we are done with the question. We are done with the question. My dear students, look at this particular question as well. Look at this particular question as well. The molar solubility of CaF2 in 0.1 molar solution of NaF will be. If I talk about CaF2, how will it undergo dissociation? Calcium dipositive aqueous. Calcium dipositive plus 2 times F negative. This is how it undergoes dissociation. Let's say its solubility is S. This concentration will be S. This will be 2 times S. Perfect. Now, since you're introducing the CaF2 in what? In NaF. How this NaF would have undergone dissociation? Na positive plus F negative. What is the concentration of NaF? 0.1 molar. In the beginning, this will be 0, this will be 0. Now this will be 0, this will be 0.1 molar, this will be 0.1 molar. Perfect. Now, first of all, do you see any common ion here? F negative is the common ion. So what is the total common ion concentration? It is 2S plus 0.1, right? And as per your common ion effect, it has to be equal to 0.1 only. It has to be equal to 0.1 only. Now, as per the question, I was supposed to get the KSP value. I was supposed to get the KSP expression. KSP expression is concentration of calcium dipositive, that's S, multiplied by concentration of F negative, that is 0.1, for stoichiometric coefficient, that is 2. As per the question, KSP value is 5.3 into 10 raised power minus 11 is equal to S multiplied by 10 raised power minus 2. So S value will come out to be 5.3 into 10 raised power minus 9 moles per liter. This is the solubility of CaF2 in NaF, which I was supposed to calculate. Okay. So this is how you try to solve these sort of questions based on your common ion effect. I'm moving on to one more question. Again, a question from the chapter solution. Someone is asking the question in the chats, how many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms? It's a simple one. It's a simple one. It's a simple one. And this is an asked question also. Okay. Remind me at the end of the session. First, let's try to solve this question. What weight of glucose must be dissolved in 100 grams of water to lower the vapor pressure by 0.2? So delta P, lowering in vapor pressure, is equal to 0.2. Okay. Now you must be knowing delta P divided by P naught. Delta P divided by P naught for a dilute solution is equal to number of moles of solute divided by number of moles of solvent. Lowering in vapor pressure as per the question is given to me as 0.2 divided by P naught. Vapor pressure of pure water, that is 54.2, is equal to number of moles of solute is mass of solute divided by molar mass of solute, which is 180. Number of moles of solvent is nothing but mass of solvent divided by molar mass of solvent, molar mass of water. Do you see you got one equation wherein you only have one unknown, that's WB. So from here, you can get the value of WB, which is the mass of non-volatile solute, which we have added over here, right? So simple formula-based question, nothing more than this. Just a formula-based question, guys. Just a formula-based question. Similarly, have an eye on this sort of one. My dear students, remember, in case of first order reactions, I'm giving you three expressions. Please remember them. Remember, time taken to complete 75% of the first order reaction is equal to 2 times half-life. Time taken to complete 87.5% of the first order reaction is equal to 3 times half-life. Time taken to complete 99.9% of the first order reaction is equal to 10 times half-life. Okay? Remember these three expressions, they are valid for your first order reactions. So by looking at it, you are going to get the answer here. You have to check time taken to complete 87.5 is equal to x times the half-life. So it's going to be 3 times the half-life. So it's option 1 that has to be the correct answer of this particular question. Am I clear? Am I clear? All right. Look at this one, guys. You have got the hydrocarbon A and it's undergoing combustion. It will lead to the formation of carbon dioxide, and with carbon dioxide, I'm going to write water. With carbon dioxide, I'm going to write water. Now, first of all, how do we balance this reaction? This is how you are going to balance the reaction. This is how the reaction is balanced. Okay, number 1. Now, as per the question, it requires 11 equivalents of oxygen. When this hydrocarbon undergoes combustion, it requires 11 equivalents of oxygen. So, x plus y by 4 is equal to 11. At the same time, 4 equivalents of water are produced. 4 equivalents of water are produced. So, I can say y by 2 is equal to 4. If y by 2 is equal to 4, that means y is equal to 8. That means y is equal to 8. And put the value of y over here. So, it's going to be x plus 8 by 4 is 2 is equal to 11. So, x value is equal to 9. So, x value is equal to 9, y value is equal to 8. If x is equal to 9, y is equal to 8. So, your hydrocarbon is going to be C9H8 over here. Simple. Okay. My dear students, one more question. You would have seen this particular question also. As per the question, BaCl2 is treated with Na3PO4. And when BaCl2 is treated with Na3PO4, it gives your barium phosphate Ba3PO4 whole twice. With this, you'll be writing NaCl. Well, when you balance the reaction, this is 3 times, this is 2, this is 1, and this is 6. The reaction is balanced. Now, as per the question, we are starting with 5 moles of BaCl2 and 2 moles of Na3PO4. So, in the beginning, this is 0, this is 0. Now, which one is limiting reagent? 5 divided by 3 is 1.6. 2 by 2, that's 1. So, your Na3PO4 becomes my limiting. So, it would have got completely consumed. And entire product formation is decided by this Na3PO4. 2 moles are giving us 1 mole. So, 1 mole will give us 1 by 2 moles. And over here, you have given it 2 moles only. So, the value comes out to be 1. So, you can directly say 1 mole of barium phosphate is formed. 1 mole of barium phosphate is formed in this particular reaction. Right? 1 mole of barium phosphate is formed in this particular reaction. Hope this is also clear. One more question from the chapter Atomic Structure. Well, this is the question from past 3-4 years in the JEE mains. They have been asking this particular question, right? So expect this sort of a question in your NEET examination as well. My dear students, incident light is falling on these metals. And incident light has got the wavelength of 400 nanometers. So what is the energy carried by incident light? Hc divided by lambda. Hc is 1240 divided by lambda is 400, right? Electron volts. So it is going to be how much? It's going to be 3.1 electron volts. So this is the incident energy. For the photoelectric effect to happen, incident energy should be greater or equal to work function. For the photoelectric effect to happen, incident energy should be greater or equal to work function. Incident energy is 3.1, which is greater than work function, greater than work function, greater than work function. Here it is less than work function, less than work function, less than work function. So there are three metals over here which are going to show the photoelectric effect. There are three metals which are going to show the photoelectric effect. I hope this is also clear to everyone. My dear students, for the decolorization of 1 mole of KMnO4, for the decolorization of 1 mole of KMnO4, moles of H2O2 required. Moles of H2O2 required. So how many moles of KMnO4 I'm given with? 1 mole, right? Moles of H2O2 I need to calculate. I need to calculate. Perfect. What is the N factor of KMnO4 in your acidic medium? That's 5. What is the N factor of H2O2? That is 2, because H2O2 gets converted into O2. KMnO4 converts H2O2 into O2, due to which its N factor is 2. If I again use the equivalent concept simply says N1 into N factor 1 is equal to N2 multiplied by N factor 2. So N1 value is 1, N factor 1 is 5, N2 is to be calculated, N factor 2 is 2. So N2 value here comes out to be 5 by 2. So 5 by 2 moles of H2O2 are required for the decolorization of 1 mole of KMnO4. Okay, remember the N factor of H2O2 directly here. When H2O2 acts as the oxidizing agent or even the reducing agent, when H2O2 acts as oxidizing agent or even the reducing agent, its N factor will be taken as 2. Its N factor will be taken as 2, right? What do you think about this one? Which of the following are the intensive properties? Volume is extensive property, molar heat capacity is intensive, molarity, concentration, that's intensive, E0 cell intensive, gives free energy extensive, right? Molar mass intensive. So how many in total? 1, 2, 3 and 4. So there are 4 terms which are the intensive properties among all. And intensive properties are the ones whose value depends on, whose value does not change on changing the size of the system. Correct? As simple. Even in the last, that short video I gave you, in that particular case, I discussed this particular question as well. I hope you remember that. I give you all the examples of extensive, intensive. All right. Now, my dear students, when 50 ml of NH3 is mixed with 10 ml of 0.1 molar HCl, so HCl is being mixed with NH3. So acid-base reaction, it will lead to the formation of your salt, which is NH4Cl. Perfect. Now, at time t is equal to 0, how many millimoles of HCl do we have? This multiplied by this, that's 1. So we have got 1 millimole of HCl. How many millimoles of NH3 we have? This multiplied by this, that's 5. So in the beginning, this is 0, right? Now, since HCl is the limiting reagent completely consumed, how much NH3 will be left? 4 millimoles of NH3 will be left, and 1 millimole of your NH4Cl would have got formed. Right? Now, my dear students, when the reaction would have stopped, in the container, you have got a weak base and you have got salt of same weak base with a strong acid. In the mixture, finally, you have got weak base and the salt of same weak base with a strong acid. So what do we get? We got a basic buffer here. We got a basic buffer. How do we calculate pOH of a basic buffer? It is equal to pKb plus log of concentration of salt divided by concentration of base. Right? What is the value of pKb? As per the question, it's 4.75 plus log of, what is the concentration of salt? Concentration of salt means millimoles of salt. Millimoles of salt divided by total volume. Total volume is 50 plus 10, 60. Whole divided by. Concentration of base means millimoles of base divided by total volume. That is 60. So 60 gets cancelled out. So I got log of 1 by 4. Log of 1 by 4 can be written as log of 4 raised power minus 1, which will be minus log 4. It will be minus log 4. Minus log 4. Log 4 is how much? 0.6. So this value comes out to be 4.75 minus 0.6 will be 4.69. So this is the pOH. What do I need to calculate? I need to calculate pH. Since you know pH plus pOH at 14 degrees centigrade, at 25 degrees centigrade is equal to 14. So pH has to be equal to 14 minus pOH, so which is going to be 14 minus 4.69. So approximate answer is going to be 9 point something, right? How much? 9.25. That is the approximate answer. Or 9.85. What exactly you're getting? Sorry, it's 9.85, right? Approximately 9.85. All clear with this? This sort of a question you should be in a position to solve. My dear students, in this particular question, you are given with the cyclic process, right? You are given with the cyclic process, you have to get the value of QAB and QCA. If you look at the AB process, this AB process here, it is isochoric. And heat absorbed or released during the isochoric process. That means heat absorbed or released at constant volume is nothing but NCV delta T for an ideal gas. What is the value of N? 1 mole of ideal gas. CV value for monatomic gas, 3/2R. Delta T, change in temperature, A to B. This is the final temperature, this is the initial. So final minus initial will be 300. So this value will be 450 R. So this is the value of your QAB. If this is QAB, what about QCA? CA process is isobaric. That means heat absorbed or released at constant pressure, which has to be equal to NCP delta T. NCP delta T. What is the value of N? N value is 1. CP value for the monatomic gas is 5/2R. T2 minus T1. The process from C to A. So this is final, this is initial. So final minus initial is minus 150. So this value will come out to be minus 375 R. Right? So you got QAB as well as QCA. So just remember one thing. Heat absorbed or released at constant volume is NCV delta T. Heat absorbed or released at constant pressure, that is NCP delta T. Accordingly, you use the formulas and get the question done. Expect this sort of a question as well. Okay? So my dear students, with this particular session ends over here. Okay? So I hope you got the idea of these were some important questions which I wanted to discuss with you, right? Because I feel the questions of the similar types, the questions of the similar patterns will be asked in your upcoming NEET examination. And at the same time, one more thing. In the upcoming days, we'll keep on coming up with more such kind of the sessions. I don't know whether thumbnail is public or not. Let me check it out. Yes, this is going to be one most important session which every one of you has to follow. That is NEET 2025 predicted paper, right? So first I'll be coming with the chemistry section. After me, it's going to be Yavar sir or Ambika ma'am and then HSP sir. Perfect. So it is scheduled on Sunday exactly at 5 p.m. On Sunday, 5 p.m., you are supposed to follow this particular session, my dear students. Okay? All right? Ritik is saying, sir, aren't these questions easy? Of course. In the NEET examination, you get easy questions only. Who told you get tough questions? You don't get questions from advanced. All right? Chalo guys, I'm going to take a leave with this. Yes. There is one session pending of thermodynamics and equilibrium that will be scheduled day after tomorrow. Okay? Perfect, guys. Chalo, I'm going to take a leave with this. See you. God bless you all.